In this video, we're going to be looking at trigonometric functions of acute angles. To begin, we're going to start looking at specifically right triangles. So we have a right triangle here with one of our angles. It's not the right angle. We don't typically evaluate trig functions for our right angle, but for our angle theta here, and we could also look at it up here as theta, but we are observing it here. And this illustrates the relationship of the sides of the triangle to that angle. So if this is angle theta, the side opposite, or the leg opposite, we refer to as the opposite side. The leg that is next to it is the adjacent side. And then the hypotenuse will always be adjacent as well, but the hypotenuse we know is a very special side of our right triangle, the longest side opposite the right angle. When we're dealing with right triangle trigonometry, there's a really wonderful acronym to help us remember the formulas that we're about to give you. The acronym is SOHCAHTOA, SOHCAHTOA. And what this represents is sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So this gives us some new formulas for sine, cosine, and tangent when we're not looking at a triangle specifically built onto a coordinate system. But the reciprocal property still exists. So now cosecant would be hypotenuse over opposite. Secant is going to be hypotenuse over adjacent. And tangent is going to be adjacent over opposite. Given the triangle, find sine, cosine, and tangent values for angles A and B in the figure. To find sine of angle A is right here. It's going to be opposite over hypotenuse. So the side opposite angle A is 4 and the hypotenuse is 5. Cosine of angle A, again, here's angle A, is the adjacent side or the adjacent leg. So 3 over the hypotenuse, 5. And tangent of A is going to be the opposite leg to A over the adjacent leg to A. So again, if here's A, the opposite is 4, the adjacent is 3. Now, let's shift our perspective and look at angle B. Angle B is down here. Now, for sine, the opposite side is 3, the hypotenuse is still 5. Cosine of B, the adjacent side to B, if here's B, adjacent is here 4, and the hypotenuse is 5. And tangent of B is opposite, so 3 over adjacent, 4. So this example does illustrate where we need to be very mindful of the position of the angle that we're looking for trig functions of. Now, looking at these values, we might observe some interesting seeming coincidences. Sine of A, which was 4/5, is equal to cosine of B, which is also 4/5. Likewise, cosine of A, which was 3/5, is equal to sine of B, which was 3/5. These are called cofunctions. And there's a few relationships that we have. We've seen the relationship between sine and cosine, but there are 2 others. So looking at this picture as our diagram, what we're trying to figure out is which trig function of A, so here's our angle A, is A over C. Well, if here's angle A is opposite, and C is the hypotenuse, so this is going to be sine of A. And we know that sine of A is equal to cosine of B. Cosine of B is adjacent over hypotenuse, or A over C, as well. The next set of cofunctions, again, trying to figure out the first one, some trig function of A is A over B. So here's our angle A, and we've got the ratio A over B, or opposite over adjacent. That's going to be tangent of A. Tangent of A is equal to, looking at angle B, this A is the adjacent and B is the opposite. That's going to be cotangent of B. C over B is our hypotenuse over the adjacent. That's going to be secant of A. And C over B with relation to angle B. Angle C is the hypotenuse, B is opposite. That's cosecant of B. Now, just one quick note here. In terms of the naming conventions of a triangle, our vertices, which are the corners of our triangle, which will be often used to represent the angle given there, we're going to use capital letters traditionally. And then the side length opposite that angle is going to be the lowercase of that variable. So notice for angle A, the side opposite that is lowercase a. For angle B, the side opposite is lowercase b. For angle C, the side opposite is lowercase c. So just a quick observation for very commonplace naming conventions when we are drawing out pictures or talking about particular parts of a triangle. Cofunction identities. These are dealing with our complementary angles. In a right triangle, if we reserve C for the right angle, A and B are always going to be complementary. And that's, again, going back to the sum of the interior angles of a triangle is 180. If all three of these angles add up to 180 and this is 90, that leaves 90 degrees left for the sum of angles A and B. So A and B are always going to be complementary. Sine of angle A is equal to cosine of 90 minus A, or cosine of its complement. And we saw this right here. Sine of angle A is equal to cosine of its complement. So A and B here were complements of one another, and we had the same trig function value. Cosine of angle A is equal to sine of its complement. Secant of angle A is equal to cosecant of its complement. Cosecant of angle A is equal to secant of its complement. Tangent of angle A is equal to cotangent of its complement. And cotangent A is equal to tangent of its complement. So this is just another way of writing exactly what we have right here. Write each function in terms of its cofunction. Cosine of 52 degrees. So thinking about cosine, its cofunction is sine. And our cofunctions are equal when we're looking at complements. So this is equal to sine of 90 minus 52, or sine of 38 degrees. So cosine of 52 degrees is equal to sine of 38 degrees. Sine of angle A minus 11. The cofunction for sine is cosine. And these functions are equal when we're looking at complements. So we're looking at 90 minus A minus 11. So this is their given angle. To find its complement, we're going to subtract it from 90. So now we want to simplify. Distributing that minus sign first. +90 plus 11 is 101. 101 minus a degrees, where we don't know the value of a. Find one solution for each equation. Assume all angles involved are acute angles. Cotangent of theta minus 8 degrees is equal to tangent of 4 theta plus 13. Remember that cotangent and tangent are cofunctions, so that means these two angles must be complementary. In this example, we're seeing theta used more traditionally like that variable x in an algebraic equation. But just keep that in mind that theta is a variable. It's just specifically used as a variable for an angle measure. So theta plus 4 theta is 5 theta. -8 plus 13 is +5. Subtract 5 from both sides, we get 5 theta is equal to 85, and theta is equal to 17. Secant of 5 theta plus 14 is equal to cosecant of 2 theta minus 8. Again, secant and cosecant are cofunctions. So these two angles, 5 theta plus 14 and 2 theta minus 8, are complementary. So we add those up and get 90. Now we simplify. 5 theta plus 2 theta is 7 theta, and 14 minus 8 is 6. Subtract 6 from both sides, we get 7 theta is equal to 84. And if we divide both sides by 7, we get theta is equal to 12.